This is Vijetha, Associate Professor from the Department of ECE, MLR Institute of Technology. Today, I would like to talk on language constructs and conventions from linear and digital integrated circuits. I have subdivided the topics and have taken these 6 topics in this video. Keywords, identifiers, whitespace characters, comments, numbers, and strings are some of the language constructs and conventions. In Verilog, we used to use many keywords and sometimes we may use whitespace characters, and it's better to use a comments while you're writing a program, and how to represent a numbers and what is the purpose of using a strings in the programming language. We'll discuss these topics in the first part of language constructs and conventions. First, we'll go with the introduction part. Verilog has its own constructs and conventions, which resembles like a C language. Any source file in Verilog is made of number of ASIC characteristics. The characters are grouped into a set referred to as a lexical tokens. Lexical tokens in Verilog can be single character or a group of characters. It may be a single character or maybe a group of characters. Basically, in Verilog, there are 7 lexical tokens. There are operators, keywords, identifiers, whitespace characters, comments, numbers, and strings. And one more important point is, Verilog is a case-sensitive language like C. For example, the common sentence, SCNSE. Here I used capital SCNSE. Here I used all the capital letters. And here I used capital EN, remaining all are small. So all these are treated different entities. It's a case-sensitive language. Verilog is a case-sensitive language. Next, the first lexical token is keywords. So what is the purpose of keywords? So keywords defines the language constructs and it carries out the activity to be performed or activity to be initiated or activity to be terminated. A program cannot use a keyword for any purpose other than it's intended for, it is specified for. The keyword is specified for particular work that can be done by using a keyword, and these keywords cannot be used for any other purpose other than the specified work. All the keywords in Verilog are in small letters and required to use as such. So, for example, here module is a keyword. The module which you are representing should be in terms of small letters itself. You should not use capital M and remaining small. These two are considered as a 2 different tasks. And the keywords, whatever the keywords which you are using here, will be there with a small letters, not with the capital letters. Here, for example, I have given some keywords here. The first one is module. What is the function of the module? It just begins the module. It just shows that you are assigning some code for this module, and this specifies that your code has been starting from this statement. And end module signifies the end of the module. That is, the code which you have written in the module has been ended, can be defined by using an end module. Begin signifies a block of statement, signifies the beginning of the block of statement. For example, if I want to use A is equals to 0, B is equals to 0, C is equals to 0 to perform B is equals to A plus B plus C, and I have assigned all 3 values. So this block of statements can be executed or can be started by using a keyword called begin. This begin specifies that the beginning of the block of statements, and the end of this block of statements can be given with the end. So begin signifies the beginning of the block of statements and end signifies the end of block of statements. and if signifies the conditional activity to be checked, while signifies the activity to be carried out. These two can be used in behavioral level, and these two can be used in test bench programs or also in behavioral level. And this module and end module will be used in all the programs, either maybe test bench or maybe a design description. Next, the next one is identifiers. Any program requires block of statements, signals, etc. to be identified with a attached name tag. So, for example, previously I have taken that A is equals to 0, B is equals to 0, C is equals to 0 to perform an operation of A plus B plus C. So, this block has to be given with a specified name, and that name tags are nothing but a identifiers. Or we can say, if I want to perform this operation only when clock is equals to 1, then I need to mention that clock. Or I want to perform this function only your enable pin is high, then I need to use the identifier. So it is good practice for us to use identifier closely related to significance of variable signals, blocks, etc. are considered. This will be easy for understanding and debugging of any programs. Examples are clock, enable, get underscore 1. These are the some identifiers. So these have been given with a specified task, and these can be called to perform that specified task. Whenever I call the clock, it shows that whether I need to check the clock is high or low. If the clock is 1, then I will ask to perform some operation, and if the clock is 0, then I will ask some other work to be done. Similarly, like enable. And similarly, for get underscore 1, I will be writing some group of statements under the get underscore 1. Whenever I want to perform some particular task, like performing an get underscore 1 is another kind of identifier which has been given to perform some particular operations like addition. Here, this is an example. This has been given with the name called get underscore 1. Whenever I want to perform addition of these three variables, I will just call the get underscore 1 so that it executes the program in the required pattern. These are some restrictions in assigning an identifier names. What are those? All the characters of alphabets or underscores can be used as the first character. For example, name, here name dot, capital name, capital N, AME, and NAMEL, NAMEJ. These are the examples I have taken here. The difference here is whatever the examples I have taken, all the variables are starting with either capital N or small n. We should start your identifier with alphabetics, not with the other characters. Okay, next. Here, see here, name A. This is not allowed as an identifier because the blank space is interrupted. Similarly, this is also not allowed because I am using a dollar in front of the name. This is also not allowed since numerical 1 is the first character. And here, at the rate is a capital letter. At the rate is the starting letter. So, this is also not allowed. And here, this is also not allowed because of the plus symbol between A and B. For example, see here, this B is equals to C, control signal because of this space, because of this, and it's not possible. And here, this is one of the identifier because it is not having any spacings or any other different symbols. Okay. So, the only allowed identifiers are like this. It should be start with the alphabetic, not with other symbols, and should not give any space or should not give any other variables in between the name, and you should not give any space. This is about identifiers. Next, white space characters. /B, /t, /n, or some of the white space characters. Generally, these are included in design description wherever you require a blank space, or to start with a new line, or to start with the whenever you require a tab space. So these are the some white space characters where you can include in your design description. They are introduced between keywords, keyword and an identifier, or maybe between two identifiers, or between identifier and operating symbols, and etc. White space characters have significance only when they appear inside the string. The next lexical token is comments. It is good practice to write a comments for design description, and these comments are of two ways. Why this is very important, why this is good practice to write the comments? Because I have written this statement. For example, I have written this statement. Some may not understand why I have written this statement. So by seeing the comment, they can understand why I have written this comment. So now comments are of two types: single line comment and double line comment. In single line comment, you need to start with the double slash. Here, for example, module, starting of the module is a keyword, and D flip-flop is the name of my program. Q is the output of D flip-flop, and DP and clock are the inputs of D flip-flop. This I know. If I can give this in terms of comments, then it will be very easy for others to read the line. So as I'm using a single line comments, I'm using a 2 slashes parallelly, and I'm writing, this is a design description of D flip-flop. Here Q is an output, DP and clock is an input. Okay. So similarly, we have multi-line comments. So multi-line comments start with the slash and star, and with the star and slash. All the lines appearing between two symbols treated as a single block comments. The same example here, instead of writing in a 3 lines, I'm writing in a single line. That module is a form of design description, and I'm writing the code for D flip-flop, where Q is an output of the flip-flop and DP and clock are the inputs of your code. And multi-line can also be nested. Multi-line comments cannot be nested. That is, see, this is the starting of the multi-line comment, and this is the ending of the multi-line comment. In this, I have used another multi-line comments. This will not be allowed. A multi-line comment should be independent. It should not be nested. These are the two different types of comments. And coming to numbers, we used to use frequently numbers in a design description. The logical state of signals, buses, delay values can be loaded into registers. Example, the numbers can be integer type or maybe a real type. If the numbers are of integer type, then it may be a signed integer or maybe an unsigned integer. And real numbers can be a decimal or scientific notation, can be specified in decimal or scientific notations. And this is a representation of numbers. This dash identifies, see, the numbers should be of consisting of 1, 2, 3, 4, 5, 6 different forms. The first one represents whether it is a signed bit. This field represents whether it is a signed bit or unsigned bit. The second field represents the number of, or we can say the width of numbers. And the tick H represents whether it is a hexadecimal or decimal or octal or binary. And F4 represents the number, and this number characteristics may be of 0, 1, X, Z. Here, especially whatever I have taken here is a 8-bit hexa. F represents the 4-bit ones, and 1 represents the 1, 0, 0, 0. 0 1 0 0. So this F4, this is a number, and this is represented in a hexadecimal number, and which is consisting of 8 bits, 1 2 3 4 5 6 7 8 bits, and this negative represents a signed bit. So this represents either a signed bit or an unsigned bit, and this 8 represents the width of your number, and this part represents the base of your number system, and these two columns are used to represent the number. Next, there are different ways of number representation in Verilog. Here I have taken few examples. These two represents the same decimal number, but the first one, these two represents the same decimal number. This here I didn't mention the base of the number, but here I mentioned the base of the number. Both are representing a decimal number of unspecified size. I didn't mention any size here. Here all these represents a 3-digit decimal number, and the capital D or small d specifies the decimal number, and underscore here can be ignored, and this is a 9-bit width. They have represented that it is a 9-bit decimal number of 439. Similarly, I will be taking this hexadecimal value. This is an hexadecimal value. See, A5 is common for all the 4 variables, and this underscore can be ignored, and this H represents the hexadecimal values, and this 8 represents the 8-bit hexadecimal value of A5. These are the some examples which can be represented in Verilog. Okay, and coming to strings. A string is a sequence of characters enclosed with the double quotes. For example, see, this is a string which is enclosed with the double string. A string must be a single line. It cannot be carried to a second line. This is a single line which cannot be carried with the second line. Special characters are specified by a preceding with this statement, that is with slash. Verilog treats a string as a sequence of ASCII characters. These are the some examples. So this will be executed in line 1, and this will be executed with a tab space. And here this is called as a string, which is defined as a special string over here. So these are the strings this is how you can implement the strings in Verilog code. And here some string formats. This %B, %D represents %small d, %capital D represents the decimal value, and this B represents the binary, S represents the string, H represents the hexadecimal value, C represents the ASCII characters, M represents the hierarchy names, this V represents the display strength, and O represents the octal value, and T represents the time format, and E represents the scientific real number in scientific format, and F represents a real number in decimal format, and G represents the scientific number in scientific or decimal, whichever is shorter. So summary. Coming to this, here I have discussed about comments. There can be a single line comment, or maybe a multiple line comment. Next, I have talked about the strings, which can be given with the double quotes, and it can be read in a single line, not in a multiple line. And the numbers, which can be represented with the signed bit, length of your bit, and base of your bit, and the number which you want to represent. And the other one is, the other topics which I have discussed are comments, white space characters. So the other topic which I have discussed is white space character, where you can use to represent a new line, to represent a space, and to represent a blank space. And I also discussed about the basic concepts related to Verilog, how to represent the identifier. It should be start with the alphabetical number, not with any other variables or any other special characteristics. Thank you.